Okay, so this is round two. Hopefully the sound comes through on this one. We're going to do the Ionic Dice worksheet. So right now it's COVID year and we can't all just roll the dice in class because we're not in class on the day that we're doing this activity. So we're going to do it as a video. And then if you're watching this in a non-COVID year, then this is just how you're going to make up the activity if you were absent. So the Ionic Dice worksheet, you're going to have 32 rows that you're going to have to fill in here with cations, anions, ionic formulas, compound names. I'm going to roll a set of dice that have cations and anions on them, and we're going to just match them up and put their formulas together and name the compound. Okay, so first roll right here, I'm just going to pull all my cations onto one side. So remember, our cations are the positively charged ions here. Okay, and then I'm going to go ahead and I'm going to match up the anions with the cations. Okay, so I'm going to put them into two columns here. Okay, so we're going to fill in the first row, 4 rows together, step by step, show you everything you're supposed to do, and then I'm going to roll the dice enough times for you to fill up the remaining 32, or to fill up the whole 32 row sheet. So if you don't have a sheet in front of you that looks like this, then what you need to do is take a piece of paper, number it 1 to 32, because the front and back of this worksheet have 32 total rows, and then you're going to make some columns across the top. So we've got compound name, we've got cation, anion, ionic formula. Okay, so for the cations, I rolled an Ag1+. Remember, we don't have to write ones here. I could have just written Ag+. I used the ones on the dice just to be more clear. Okay, Pb2+, Sn2+, and Na1+. Okay, so again, 4 dice, 4 rows. I'm not putting all of those in the same box. Then for my anions, I have As3-, NO3 1-, P3-, and HCO3, all capitals there, hydrogen, carbon, oxygen, 1-. Okay, so there we go. I'm done with the dice for this roll, but I'm going to go through the steps that you're supposed to use to make the formulas and the names. Okay, so again, our ionic formula, all ionic compounds are going to be neutral, so these ions have to balance each other. So 3 doesn't balance 1, so we would need 3 of these to balance that -3 and end up having a +3 charge from those ions. Another way that you can think about this is we're doing a little switcheroo. I'm going to just draw a couple arrows here. The number from arsenic's charge is going to come down here as a subscript for silver. The number for silver is going to come down here. Not the plus or minus, just the number. And remember, we don't write ones when we write formulas. So the 3 comes down with the silver, so we get Ag3, and then As1, but we don't write ones. So Ag3As is going to be the formula for that. 3 positive ones will balance a -3 ion. Now when we name these, the cation gets to keep its name, silver, and the anion, when it's a single element, single atom like that with a negative charge, its name changes to ide. Okay, so arsenic becomes arsenide. Now remember, with our cations, you have to think about whether they're transition metals or not, because our transition metals are going to need Roman numerals. Because our transition metals have more than one possible charge, a Roman numeral will tell us which charge that ion had. So let's just refresh which ones are our transition metals real quick. Okay, so here, group 1 is the alkaline metals. Those do not need a Roman numeral. They're always a +1, so we don't need a Roman numeral to tell us their charge. Group 2 is our alkaline earth metals. They do not need a Roman numeral. They are always a +2. Aluminum is always a +3, so it does not need a Roman numeral. But our transition metals are the D block and the P block metals down here, not aluminum, but these ones. Typically, those ones are going to need a Roman numeral to tell us the charge. But there are 3 exceptions. The 3 exceptions are zinc, cadmium, and silver. Okay, so this little backwards L shape right here, zinc, cadmium, and silver. Zinc and cadmium are always a +2, and if you want a way to remember that, they're in group 2B. Silver is always a +1, and it's in 1B. And so that doesn't apply to all of them, but if you can remember, it's these 3, those group numbers can help you remember their charges, okay? So silver in this case, even though it's in the transition metals, it does not need a Roman numeral. Okay, next one, our PB 2 plus, NO3 1 minus, those do not balance. If they balanced already, we would just put them together without writing the charges, okay? But they don't balance. So I'm gonna bring this 2 down here with the nitrate. I'm gonna bring this 1 down here with the lead, which I don't need to write a 1. So PB, only one of them, and then 2 nitrates, so NO3 2. Now, if I leave it written this way, this looks like 32 oxygens. We don't want 32 oxygens. We want 2 nitrates. So we have to put nitrate in parentheses with that 2 on the outside in order to make those 2 nitrates balance that lead. All right, over here, PB is lead. We look at the periodic table for its name. It is a transition metal, so I need to use a Roman numeral. And remember, the Roman numeral tells me the charge. It's not telling me how many leads are in the compound. It's telling me what the charge of the lead is. In this case, it's a 2 plus, so Roman numeral 2. And then NO3 is one of our polyatomics. That one is called nitrate. So when you have a polyatomic ion, you just use its name. You don't change it in any way, okay? All right, SN2 plus with P3 minus. Again, if I do that switcheroo, this 3 comes down as a subscript with the SN. This 2 comes down as a subscript with the P. So I'm gonna get SN3, P2. That makes them balanced. SN is tin. It is a transition metal. It can have more than one charge, so I have to put the 2 in parentheses, the Roman numeral, to tell me its charge. And then P is phosphorus, but with that -3 charge, it becomes phosphide. So this is tin 2 phosphide. All right, last one for this first roll here. We have an Na 1 plus and HCO3 1 minus. Those are already balanced, so we just get to squeeze them together. Na HCO3. Okay, we don't write the 1 plus and the 1 minus, but we put them together and they balance each other. Okay, Na is sodium. It's an alkali metal. It doesn't need a Roman numeral. HCO3 is bicarbonate. Sodium bicarbonate, also known as baking soda, okay? Now, hydrogen carbonate is also an acceptable name because that's what our textbook uses, but remember, bi means hydrogen in chemistry, so bicarbonate is gonna be a much more common name for that anion. Okay, I'm gonna roll the dice 7 more times so that you can fill up the remaining slots for your 32 different compounds. You're gonna pause the video as you need in order to write down your cations and your anions. I'll match them up so that we're all doing the same and you can use the answer key to help you check your answers a little bit quicker, okay? So here comes the first roll of our 7 that we need to use to complete this table, okay? So there's that, and we have all 1 minus charges. Look at that. Okay, so go ahead and copy those 4 into the next 4 rows. This one's NO2 1 minus in case you can't read that one. Whoop. All right, that was 1. Here comes roll number 2. Roll number 2. Okay, so this one is C2H3O2. It can also be written as CH3COO, but this is more common if you're not in an organic chemistry class. This one's a repeat. We already had NO2 1 minus. All right, here comes roll number 3. All right. There we go, roll number 3. All right, there's roll number 4. Wait, that might have only been roll number 3. Now I already lost count. Look at that. Okay. I'm going to pretend like this is roll number 4 and act like I know what I'm talking about. And then if you end up with an extra roll, you can have some extra practice, but not required, of course. Okay. So I'm going to say this is roll number 4. Number 5. Number 6. And hopefully I'm right when I say number 7. I'm gonna roll this one again. We've had a lot of the same over here. Okay. I'm gonna roll this one again too. That sodium really likes to pop up. Okay. Okay, there's number 7. If I cut you shorter roll, then you have less work to do, but I'm pretty sure I got at least 7, maybe 8 on that one. So get those done and then look at the answer key. Email us if you have any questions. And you will have a quiz that's a lot like this where you're going to roll the dice. So get this in there as practice, memorize your polyatomics. If you need more practice, come borrow some dice from us. But we will do a quiz where you roll the dice. So see you guys in class.